Welcome. This is a webinar offered by the North Atlantic Fire Science Exchange in partnership with a number of folks that you will hear from momentarily. We're really excited to talk about the Dome in Vermont, and just a little bit about the format for today. We're mixing up our typical webinar format a little bit. What we've done is our presenters have pre-recorded a really nice video, which you all should have received the link to, and so you can watch it again later. But it's broken into segments, so our speakers take turns sharing really important information about the Dome. We're going to play those segments. Each segment is just a few minutes long. And then we will come back and have discussions about what's happening. So rather than give lengthy introductions, I wanted to give just brief introductions to folks that are our speakers for today. So I'm going to, I'll start it off briefly and then I'll pass it over. So my name is Amanda Mahaffey. I am part of the North Atlantic Fire Science Exchange. And I am today zooming in from the Wells Barrens Preserve in southern Maine. And I'm going to pass it to Lindsay.
Hi, good morning, everyone. Nice to see so many people on. I'm Lindsay Ray Sylvia. I'm the fuels technician on the Green Mountain and Finger Lakes, and I'm based out of Vermont.
Thank you, Lindsay. Let's pass it over to Jeff.
Good morning. I'm Jeff Tilley. I'm the forestry program lead and the forest silviculturist on the Green Mountain and Finger Lakes National Forest.
Awesome. Thank you. Let's have Randy go next.
Good morning, everyone. Randy Swati here, presenting and participating from the Vermont chapter of the Nature Conservancy's office in Montpelier. I typically work for the Nature Conservancy's land fire team and live in Marquette, Michigan. So if you have local TNC questions, you'll connect with the Vermont chapter, and I provide national scale GIS support.
Thank you, Randy. And Suzanne.
Good morning, everyone. I'm Suzanne Gifford, ecologist and wildlife biologist for Green Mountain and Finger Lakes National Forests, also based in Vermont.
Fantastic. Thank you all so much. I will briefly point out, if you're not familiar with the North Atlantic Fire Science Exchange, Regina shared a link in the chat. And also, we actually have an introduction video if you aren't familiar with NAFC for some reason. So you can watch that at your leisure. But for now, I encourage you to click on the YouTube link that Maddie has shared in the chat window so that you can listen and watch the recording.
Hello, everyone. My name is Lindsay Ray Sylvia. I'm the fuels technician for the Green Mountain and Finger Lakes National Forest. And I'm very thankful to have the NAFC team here to bring us all together and help highlight the work that's been going on for these fire adapted communities, oak pine communities at the Dome in southern Vermont. There have been a lot of partner and collaborative efforts for the last 10 years on this project, and we're looking forward to further inputs and feedbacks, successes, trial and errors from any of you who have been doing this kind of work in northern New England especially, and just looking forward to what the day and then the field day has in store. Please let me introduce Jeff Tilley. Jeff has been the project lead for the Dome oak restoration work, and he'll provide the background and we'll take it from there. Thank you.
Hi, my name's Jeff Tilley. I'm a forester and silviculturist on the Green Mountain and Finger Lakes National Forest. And I'm here to give you a little bit of background, a little overview on this project here at the Dome. It's a small but unique area on the National Forest, all the way on the southern edge of the forest. There's a mountain called the Dome, which sits along the western slopes of the Green Mountains. And it has a south-facing ridge line that descends to the Massachusetts border. And it's along this ridge that we see an extensive area of dry oak forest. And you can see that here in this mapping done for us by the University of Vermont Natural Community Mapping. There's this dark red area that shows a dry oak forest with a well-developed heath, huckleberry heath, and scattered red pine along the ridge. And then on the flanks of this ridge, on the upper and mid slopes, is dry oak forest with a well-developed beech mid-story and understory. So that's the beech variant. We've got some additional dry oak forest mapped up here. And then on these lower slopes to the west, there's still quite a bit of oak. These are more productive soils, deeper soils, and the oak is mixed with northern hardwoods and some white pine as well. So as silviculturists and ecologists on the National Forest, we get excited about the opportunity to work with this type of habitat. Oak makes up less than 4% of Vermont's forests and less than 1% of the National Forest. So it's pretty uncommon here, not to mention this type of more diverse, well-developed oak habitat. And Randy's going to be telling us a little bit more about the context of oak on the landscape in a few minutes. Where we do find oak, it's usually the legacy of past agricultural disturbance, generally pasture, where grazing and other disturbances help the oak to get established. But on many of these sites, northern hardwoods are more competitive long-term, is what we find, and stands are moving in that northern hardwood direction over time. We have some of that trajectory toward northern hardwoods here at the Dome, but oak is much more competitive here, largely due to the soil conditions and aspect, and also due to past disturbance. So there's some images here on the story map which give you an idea of what some of the area looks like. The overstory is predominantly oak, as you would expect. And red oak is most common, but there's also white oak, chestnut oak, and even some black oak. There's a rich diversity of species in the understory, including black huckleberry and blueberry, pink azalea, sheep laurel, teaberry, and sassafras. This is the only place in Vermont that I've seen sassafras. There's at least 17 plant species here at the Dome that are listed as rare or uncommon, including the large world begonia, and which we'll also hear more about. And there's several of these species are declining on the site. So you see in this picture, there's an example of dry oak woodland with a huckleberry heath and some scattered red pine. You can see the bedrock at the surface, indicative of those shallow soils. And you'll see the short trees as a result, and the relatively open canopy, kind of an oak woodland. Bracken fern is also common and plentiful in this huckleberry heath, and we see some northern hardwoods mixed in, paper birch and red maple. As you move down the slope, the canopy remains dominated by oak, but you see a transition to more well-developed understory and midstory of beech. And you'll see that the soils are still pretty shallow, but the beech is increasing shade and moisture and limiting the oak regeneration and shrub development here. Even further down slope, more productive soils, but at least in this spot, you don't see the beech competition so much. And so there's still this rich understory of shrubs, in this case, a lot of azalea, it looks like. So well-drained soils and shallow soils have certainly played a role in the development of the plant communities here, but disturbance, including fire, has also played a role. There's evidence of frequent fire return intervals during the 19th century into the early 20th century. This cross-section, or cookie here, was taken from a 150-year-old red pine on the Dome. As Dr. Mike Stambaugh at the University of Missouri analyzed it in 2015 and confirmed fire damage at the base of the stem resulting from at least 4 separate fire events between 1881 and 1911. So at least during that time, fire return interval was pretty frequent. We've also found written observations of the Dome in the early 1900s that describe blackened snags and as evidence of fires set by blueberry harvesters and vast plains of blueberry heath. So we know less about the fire return interval prior to the 1800s, but based on what we know about the use of fire by native peoples in New England, it seems very possible that fire has been used as a tool on this landscape for a long time. And it's easy to imagine that the maintenance of vast blueberry or huckleberry plains using fire was not a practice that started in the late 1800s, but one that was continued over a longer span of time. So the diverse fire and drought-adapted plant communities present today would seem to support this, especially the presence of long-lived fire-adaptive species like this red pine. We do know that since about 1920, fire has not really had a role in this area. There have been no documented fires really worth mentioning. And over the last 100 years, disturbance has been limited to some logging on the lower slopes, some patchy wind events, and spongy moth defoliation in the 90s. And then more recently, the last couple of years, we've seen some defoliation as well. So during this time, more mesophytic northern hardwood species like beech and red maple and birches have become more established in a lot of this area, and they're creating shadier, more wet conditions in the understory. So that evidence of mesification at the dome is strong in much of the area currently dominated by oak, and especially where it's mixed with northern hardwoods and in areas of deeper soils, generally the lower elevations. But oak still dominates the overstory even at those lower elevations, and beech has become thick under the canopy, and we don't see much oak in the understory or oak regeneration. So in the absence of significant disturbance, the trajectory of these areas is now moving toward beech, maple, and birch forests in the future. On the droughtiest soil, there along the ridge top and in those areas shallow to bedrock that we discussed, the dry oak forest is likely more stable. These areas are pretty dry and the canopies are pretty open. The stressful conditions of those droughty acidic soils will probably keep this habitat looking that way for foreseeable future. But we're still seeing areas of mesification, and there's potential for these to coalesce even in these drier areas. So that was a little overview, which hopefully gives you a sense of the landscape we're dealing with.
All right. Come on back to the main webinar. And if you have questions, please feel free to type them into the chat. So Jeff, you're getting, I assume this question is for you, Jeff, about beech bark disease. So first, Matt's asking a question. Is beech bark disease an issue? I know you talked about it in a little bit, but if you can address that out loud, that'd be great.
Yes, beech bark disease is definitely an issue there at the dome, like it is most places in New England, southern Vermont. We have, and that's part of the problem with the sprouting response to the stress on the trees, so that it creates more of a thick beech thicket that it's hard for other tree species to compete with. Interestingly, and we've found this on other kind of well-drained south and west facing slopes, there is quite a bit of disease-resistant beech in the area as well, but mostly kind of mid-slope and lower slope on the hill on the southern and western sides. And we've been doing some work to try to identify those and protect those.
Thanks. And can you remind me, so the beech, is that understory or mid-story or kind of a combination?
It's a combination, but generally it's mid-story and understory. The overstory on the dome is predominantly oak, so the beech is coming in underneath.
Great. Thank you, Jeff. Another question is, what's the elevation relative to the surrounding area? You know, what's kind of the highest peak in the area?
Ooh, that's a good question. I don't know exactly off the top of my head. I think the valley bottom there is probably around 800 feet, 700-800 feet. So as we go up the slopes of the dome, you're up 1,000, 1,200. That ridge might be around 1,400. I can double check that and throw it in the chat later.
Lindsay, got it.
Yep.
Go ahead, Lindsay.
Yep. Jeff, you're spot on. It's about 2,100 at the top of the dome.
At the very top, up in the spruce fir.
Right.
Okay.
Right. So, yeah, give or take a couple hundred feet. Maybe the very top would be 1,800.
Yeah, the top. So that south facing ridge that we're working on is down below the top of the peak, because it does transition into like more northern hardwoods and spruce fir as you get higher up. But so it's probably in the mid to upper thousands.
All right, thanks. Andy asked a good question. If we could post a link to the story map. So a little background here. No, we cannot post the link to the story map quite yet. It'll take a little while before we're allowed to. And that's one of the reasons why we decided to do this video sharing format, so that you can see the ongoing work in the story map before it is allowed to be shared more broadly. So sorry about that, Andy, and everybody who wants the link, but at least you can watch the video and ask questions live of the people that put it together now. Let's see, beyond elevation. Oh, Tom is asking, has that detailed natural community mapping been done for the entire state of Vermont?
I would say not detailed. There's been some coarse scale natural community mapping done, and the state's done a bit of that type of work, VCE and with the Vermont Conservation Design, but not on the level of detail that we're looking at here in the dome that the folks at UVM provided us.
Yeah, thank you for that. So we're going to, in a moment, start sharing the screen and get our next segment going. This one is briefer. It's about just a few minutes long, and then we'll have some questions for Randy after that.
Hello, fire ecology community. I am Randy Swati, an ecologist with the Nature Conservancy's land fire team. In this video, I'm going to walk you through our 2022 assessment of the historical fire regimes of the Green Mountain National Forest in Vermont in service to the land managers there. We'll look at how many acres of each ecosystem would have occurred historically, how many acres would have burned every year historically, then zoom in to some stands that currently have oaks in them. My hope is that this will provide context for fire management in the area and provide fodder for fun conversations. We used Landfire's biophysical settings data and models to quantify the historical vegetation in the Green Mountain National Forest. Green Mountain National Forest ecosystems are ordered from the most dominant to the least dominant here. The most fire-adapted ecosystems are the Central Appalachian Dry Oak Pine Forest and the Laurentian Acadian Northern Pine Oak Forest. Historically, across the Green Mountain National Forest, annual acres burned totaled around 3,000 acres. All of this information is easily extracted from the Landfire biophysical settings products. These maps show the narrow corridor of ecosystems where fire was most dominant on the landscape. The dark pink areas had mean fire return intervals of around 6 years, with most fires being surface fires. With so many abiotic and biotic fluctuations occurring as a result of climate change, severe weather, pests, invasives, all of it, you may be asking yourself, what's the point of looking backward at historical fire regimes and ecosystems? It's a great question. First, if we're considering the reintroduction of fire, we'll want to do it in the places where the ecological payoff is the greatest. For example, by excluding fire in oak and pine ecosystems, we may observe a species shift to mesophytic maple and beech species. Due to water use characteristics, these trees may be more vulnerable to the warming, drying climate shifts that may result from climate change. In the right locations, restoration of fire-adapted ecosystems can lead to increased climate resilience. Here, I use the data provided by the Green Mountain National Forest to filter out stands where foresters identified oak species as a way to explore places that might benefit from the reintroduction of fire. I'm excited for this work on the Green Mountain National Forest. It's not like the West, where some forests could use hundreds of thousands of acres of restoration to return fire-adapted ecosystems to their former glory. While challenging, this work seems doable. Also, these ecosystems are relatively rare in Vermont, making me wonder what surprises they hold and wanting to see them. I hope these charts and maps pique your interest and help to prioritize where restoration of fire-adapted ecosystems might be most appropriate and successful.
Randy, that was a really neat video. I'm really glad that we got to capture that one for posterity. Thanks for sharing that. Before we dive into our first question, which Ali has typed in the chat, Randy, did you have any just kind of additional comments you wanted to throw in there about Landfire, about this project in particular?
Yeah, thanks, Amanda and Alexandra, looking forward to your question. Landfire is a national program, as you may know, that maps historical and current vegetation patterns and maps current and historic fire regimes. So that's in service of fire management across the country. So I'll be the first to tell you I'm not from Vermont, and really look forward to conversations with you on how we might refine what I've presented here. Alexandra, great question. So first we mapped where the ecosystems were using abiotic factors and a regression process. So we use superficial geology, soils, climate, and other factors like that to say where the ecosystems were. Then the fire regimes were modeled using SynchroSim, a state and transition modeling software. And we had to input the annual return interval, or the annual disturbance probability of all disturbances we could, natural disturbances that is, such as insects and pests, beaver, fire, buffalo out in the Midwest and Great Plains. So we tried to find return intervals and annual probabilities for all those disturbances, and we entered those parameters into the model. That information, as you might imagine, is hard to come by. So we used expert opinion, we used dendrochronology studies, we looked at General Land Office survey notes, other literature to try to get those annual probabilities that the disturbances would happen. We ran the model for roughly 1,000 years just so it would equilibrate over time. We weren't modeling a specific time period, but trying to capture pre-European colonization. So if anyone's interested, I'm happy to do a Zoom with one person or a group of people to go into the state and transition modeling. And talking to folks in the Green Mountain National Forest, I think it'd be really great to get expert opinion of those models and get some more local information. I think some of you may have even contributed to the models back in the day, but always more review is great. So yeah, thanks for that question, Alexandra.
Awesome, and thanks for the response, Randy. I know a lot of folks in the Northeast are still getting used to using Landfire as a regular go-to tool, and so really understanding how those data are utilized is really really helpful. Let's see, I'm not seeing any other questions in the chat at the moment. I think we can allow folks to unmute. So if I don't know if Virginia or Maddie is in charge of that. I think Virginia will allow folks to unmute. Permission granted. So if you have a question you'd like to ask out loud, we'll give you a moment here to ask a question out loud.
Hi, Chris. Great question. So I have to quickly look at the maps. Yes, that is 3,000 acres per year prior to European colonization, forest-wide. And that, I believe, is the proclamation boundary, not the ownership boundary. And I'll also just tag on that I believe, working across the country, if anything, I get feedback that our fire mounts are under modeled, which is interesting. So anyways, yes, 3,000 acres is roughly the amount across the proclamation boundary of the National Forest prior to European colonization.
Yeah, thanks, Randy. To follow up on that, so you're saying prior to European colonization. So are you putting that end date at like when? 1620s or?
That's a great question and difficult to answer. So it's a generic term. We didn't necessarily put a specific end date. The idea is to capture natural disturbance regimes, and we included indigenous burning in that, which is also a point of conversation as well. But I can't really give you a specific year date.
Okay,
And
thanks.
I might lean on Lindsay or Suzanne to answer total acres of Green Mountain National Forest. I do not remember what that is.
Sure. If the question is the total acreage of Green Mountain National Forest is approximately 400,000.
All right.
I would add that the proclamation boundary area is considerably larger. So if the analysis was done using the proclamation area boundary, that would be a much smaller proportion than it would be of that 400,000. It also includes, the proclamation boundary includes a big chunk in the southwestern corner of Vermont, in Bennington County and the Taconics there. And in that valley area south of Bennington, which showed a lot of in the land fire model that was an area that showed probably the most fire in southern Vermont.
Great, thank you. If it isn't clear to you already, then the dome is a really unique and special and pretty magical ecological region within Vermont and within the Green Mountain National Forest. So it's pretty exciting that folks here are able to share detailed information and more details to come about what's going on ecologically there and how they're trying to use different management techniques to restore and enhance some of those features. I see a question in the chat. So Shlamaya says, you mentioned mean fire return intervals about 6 years at most, with most of them surface fires. The previous presentation looked at MFRI based on scars, but my understanding is that light surface fires are most common and often don't leave scars. How do you figure surface burn interval without scars? And yeah, so it's a good question. Thank you for raising that.
Yeah, exactly. That is an incredible question and a difficult one for me. I am not a dendrochronologist or specifically a fire ecologist. I can tell you how the modelers, the experts, tended to think about this. They would use literature, and I don't know exactly how the folks in the primary research would have done this. We also did a bit of an iterative sort of approach. So we might have General Land Office survey notes or other expert opinion or other anecdotal information that would describe the historical structure of the forests. And in the modeling work, it would be iterative, going back and forth, where we would try, a range, a reasonable range, we hoped, of fire regimes, and see how that impacted the structural characteristics. So it was a bit back and forth on that. So not the greatest answer for you. I would love to follow up with you more, and I would be happy to dig into the specific literature that was used in the Northeast to get at that. And please, if others here have more information on that, please chime in. I would love to hear your thoughts on that. Bob, I would have to, so in the charts I presented just the top most biophysical settings and their return intervals. I would have to dig in. I think that the pitch pine types were embedded within the biophysical settings that we have shown here, probably specifically the northern pine oak type. I don't have that on the top of my head if that's the case, but I would need to follow up on that. So I'm guessing, Amanda, you will be saving the chat so I can follow up with folks.
I just want to make sure we are capturing the chat questions and comments out loud. So I guess Bob's question for the record was, is there much pitch pine included in the communities? And if not, why does it not have a greater presence? We will get into that a little bit more as we learn about monitoring. But also just kind of following up on the surface fire question, Brenda mentioned even the lightest surface fires will leave evidence of the burn on an existing fire scar. Oh boy. I think I want to save some of the fire scar discussion for later, and I hope that Chris Gitterman can stick around. So we should definitely pick up on that. I also just want to mention out loud that in the northeastern United States, we know more current fire history based on more current methods, but indigenous peoples have been stewarding these lands for generations and generations and generations. And there's a lot that today that we don't know about the original stewards of the land and what was part of that. So we're trying to use science today to better understand where these ecosystems are coming from to help inform how we might restore and manage them into the future. So not the easiest questions to answer right now, but we're doing what we can to try to maintain ecosystem integrity and resilience going forward. Let me see. Maddie dropped a link to a paper describing proxies into the chat, so hopefully that's helpful. Aaron responded to Bob that there's no pitch pine at this site anywhere, but there is a good deal of red pine. So that's currently what we're seeing. the chat is blowing up. Everybody's really interesting. Dr. Patterson says, specifically for red pine, once scarred as about a 50-year-old tree, pitch from the bleeding scar will catch fire in subsequent fires, even low intensity ones, and add a record of those fires. I think we definitely need to add fire scars to our broader chat agenda. And Tim reminds us that there are pitch pine stands nearby, west and south of the dome. So good reminder that those are in the area. And Lauren, please, I hope you can stick around, Lauren, for the fire scar discussion. Lauren agrees with Brenda and Bill. A fire scar made on a young tree is likely to scar again, even in a light fire. It is true that light surface fires will not scar adult trees with thick bark that have never been scarred before. And Diane has seen those. Diane is an ecologist, has been an ecologist with the Green Mountain. So really excellent discussion. And I'll make a note that we want to talk about fire scars in a little while, but I do think we should probably continue with the video presentation. So we'll check in with you in 7 minutes. Enjoy the video.
So our work on this project has been going on for some time. It began with planning and stakeholder engagement way back in 2013 as part of the South Route 9 Integrated Resource Project. We worked with the research and land management communities as well as with the public to develop a management approach for the dome. And some of you joining us today were part of this effort and probably recall some of those discussions. There was some discussion and debate about the best strategies to use to manage the area. How do we best enhance and maintain this habitat? And is fire the right tool to use to do that? There was debate about the extent to which these plant communities were shaped by disturbance to begin with, and then how much were shaped by site factors such as the shallow, well-drained acidic soils that we've discussed. So these are relevant questions in determining how best to manage the area moving forward. The project decision ended up including a whole list of activities designed to enhance oak, not just here on this dry ridge, but on over 1,000 acres in the South Route 9 area, the dome area. And the treatments included prescribed fire, mechanical treatments, commercial harvests, and various control of beach competition. The decision also took an adaptive management approach that would involve monitoring and adjusting treatments as needed to meet objectives. As part of the adaptive management approach, it was decided that a portion of the area on the east side of the ridge would not be treated at all and would serve as a control or a reserve. And you can see that here outlined in black. And the treatment area on the west side, outlined in blue, prescribed fire would be used 3 to 4 times over the next 10 to 15 years to restore dry oak woodland, and then once every 5 to 30 years to maintain it. So by managing one half and by leaving one half as a control, we could evaluate success and adapt treatments as needed. To that end, a monitoring plan was drafted in 2017, which established a protocol for monitoring both vegetation and fire effects. The plan specified a total of 16 plots to be established in each the treatment area and the control. And you can see those here, the green and red circles. So within the treatment area, we have 16 vegetation monitoring plots, and then 8 of those are also serve as fire effects measurement plots, and those are shown in red. And then we've got the 16 vegetation monitoring plots in the control. In both the treatment and the control, the plots were divided equally between the heath woodland variant in red and the beach variant in green. And the plots were monumented so that data would be collected on the same plots at each entry. The monitoring plan also includes short and long-term objectives for the area, including specific targets for increasing the oak regeneration or oak species in general and other fire adapted vegetation, as well as for decreasing interfering and mesophytic competition. So these baseline plots data was collected in both the treatment and control in 2017, and the first burn was then implemented in the spring of 2019. Following the burn, botanical monitoring was conducted to assess the fire effects on the rare plant large world pogonia. And Lindsay's going to talk more about the burn and the fire effects monitoring. We also collected vegetation data again on those 16 plots in the treatment area and in 2019 later in the growing season. So at the same time we're working with this core treatment area, we're also looking at opportunities to enhance oak habitat in the surrounding stands and trying to work out what type of role fire should play in these efforts. Many of the stands on the mid to lower slopes, as I mentioned, are also dominated by oak, but they're on much more productive soils. So we're also looking at commercial timber harvest as a tool to meet our objectives there. And we know that in order to be successful in regenerating oak, we need to first establish it in the understory before we mess around with the overstory. So we've been working on that in these places. In 2019, we did a non-commercial site preparation treatment in the northwestern area here in blue. And there was, in this area, there was less competition from beech and more advanced oak regeneration. And the idea was to remove a lot of that northern hardwood competition in the midstory and understory to release the oak. And portions of this area were also planted with additional red and white oak seedlings to add and supplement that natural stocking. In two other stands, we had a canopy of oak over a dense midstory of beech. These are these lighter blue areas here, adjacent to our treatment area. And most of that beech is heavily affected by beech bark disease. In these stands, we've been conducting some trials with cut stump herbicide treatment, which involves cutting select beech trees and treating the stump with a glyphosate solution. That solution then translocates through the roots of the cut tree and kills sprouts and suckers of other beech trees connected to the root system. So this technique's been used a lot of other places, but it's new on the Green Mountain National Forest, and it was a learning experience for us. We weren't successful in eliminating beech competition from the stands, but we did significantly reduce that competition. We were able to create enough light and space to plant some oak seedlings in these stands as well and get those established. So we'll be continuing to work on oak regeneration in these areas. In 2022, we conducted another prescribed burn this spring. And we were able to extend that burn into some of those mid-slope stands to the west, these blue areas, and in between these and up in this northwestern area, where we had done some mid-story removal. So we tried to avoid burning in the planted stands, since there's a good chance those seedlings were not well established enough to survive a burn. And then following the 2022 burn, we again conducted burn severity monitoring and vegetation monitoring in the treatments toward the end of the growing season. And we'll be using that data to figure out what our next steps should be.
All right. Welcome back. So in that last segment, Jeff talked a little bit about some of the monitoring work that's been going on and gave a little bit more detail about the specific areas and natural communities that they've been looking at. We have a question in the chat from Andy saying, are you concerned that the control area is an easterly aspect and the treatment area is a westerly aspect? How are expected differences across this topographical variation addressed in the data?
No, that's an excellent point. I mean, it is, there are some variables here. So this isn't like formal replicated research. So that the top of so I guess it's a little more apples and apples right along that, the top of that ridge. It's fairly flat where the trail runs up. And is it on the shoulders of the ridge? I think there's the plant communities are very, very similar on either side. But yeah, I mean, there's definitely some differences there, and so that's something that we'll be trying to take into account. But again, we're not doing formal replicated research here, but more just adaptive management. So we'll be it's not perfect.
Nothing's perfect, except in the textbooks. So if you're dealing with reality, Jeff. You had a follow-up question, let's see, about will you suppress fire in the control area?
I think I can answer that. Is that question mostly about if we experience a spot fire during prescribed fire operations or just a general fire suppression from a wildland fire?
I don't know. Maybe you could address both. If you do have a spot fire during a controlled burn, would you suppress it in the controlled area?
Yeah, yes, we would. We would typically allow it to, grow in a small amount of size until control and suppression arrive on scene. Right? There's a lot of ground to cover, so who knows how much it would actually consume, as far as like how maybe an acre of vegetation, provided local fuel fire conditions. And same for if it is a wildland fire. Yep, we would do general suppression strategies and tactics. It is not in an area where we would typically manage fire for resource benefit. There are only some designated areas on the Green Mountain National Forest where we could do those sort of modified suppression strategies. I hope that answers the question.
Yeah, I think so. Thank you, Lindsay. And we are about to have a segment on fire in just a moment. You have another question from Shamaya. She's asking, can you tell more about how you went about planting? Also, how do you deal with deer on the seedlings? We are going to talk about deer in a little bit, but can you talk a little bit more about the planting?
Sure. So as far as the planting, so that was all mostly done under contract, and deer is definitely a concern here. A lot of the Green Mountain National Forest, it's fairly large tracts of forest along the spine of the Green Mountains, and the deer densities are relatively low, so we don't have a lot of the issues that we have elsewhere in New England, especially southern New England. But the Dome area in particular, it kind of serves as like a hardwood deer yard. It's a south-facing slope. There's lots of acorns, a lot of years. So the deer densities, and it's kind of low elevation, toe slope near the valley. So there's a fair amount of deer. So in some of the planting, we used shelters for a portion of the seedlings that we planted to kind of prevent deer browse. But we know it's going to be an issue. And we're monitoring that as well, because we haven't sheltered all the seedlings. But the seedlings were done under contract, planted under contract. They were planted at various spacings, depending on the stand and our objectives there. And the seedlings were sourced from the New Hampshire State Nursery. And I believe they were just 1.0 seedlings. With oak, if they grow out too much at the nursery, the roots because they put so much energy into their roots early on, the roots get really unmanageable for planting. So we plant them pretty small. But at least in that northwestern planting, there was quite a lot of natural regen there that we were working with. We were just planting to kind of fill in the holes where we didn't have as much. So we're hoping that the natural regen, I mean, that's really ideal. It's cheaper. It's a native seed source. It's a better way to go if we can make it happen. Oh, and as far as I see, there's another question about the species planted. It was red oak and white oak. It was a mix of red oak and white oak.
Great, thank you, Jeff. Lots of great questions about seedlings and planting. I think let's allow folks to unmute if you have a question that you would like to ask out loud. We have a question in the chat from Michelle. Did you take into account expected transitions of species given future climate scenarios?
Yeah, I mean, we're always anymore. We're always taking into account different climate scenarios. So, I mean, most of the research, the modeling has shown red oak to be a climate winner. We take all that with a little bit of a grain of salt, but especially on these type of sites where we've got droughty soils, we've got oak communities that are better adapted to drought than some of the northern hardwood species that are encroaching there. Kind of that oak pine and oak heath kind of community seems at least like a better adapted. It's a historic plant community there, but it also seems like a better adapted plant community for future climate. So that's part of the push to help to restore and maintain that plant community there.
Yeah, thanks for that. I just typed in the chat Okay, so clarification on a question. So what is your fire return interval that may cause mortality in the young seedlings, and also what size are your units? And sorry, are you asking about burn unit size? If you could type in the chat or say out loud. So fire return. Okay, so yes. So Jeff, I think the question, and maybe also for Lindsay, what is your fire return interval that may cause mortality in the young seedlings, and what size are your burn units?
I can get the seedling question. So I mean, that's definitely, if we're managing for oak specifically, the return intervals on the fire make a big difference, right? So that's a good point, because if you get a crop of if you get a bumper crop of acorns and you get all these oak seedlings established, and you burn before they have a chance to establish a root system and resprout, then you'll kill off that crop of oak seedlings. So typically, if we're using fire as a tool to manage specifically for oak regeneration, then we want to be really careful about when we introduce fire into that landscape. In this kind of main on this ridge, in this management area that we're discussing, we're I guess managing less specifically for oak and more for this habitat community overall, for this natural community. And so we're also focusing initially on reducing the competition. So it's not going to help us if we get a bumper crop of acorns and establish some oak seedlings if they're under a shade of beech midstory and they don't have enough light to get established anyway. So at least at this point, we're kind of focusing on just reducing competition, just introducing fire to the landscape. The return intervals are more based on, there is some consideration of establishing oak with the return intervals. So we're going several years between burns so that seedlings that are established could have a chance. But there's only so much that we can do, at least right now, with the timing too, with just other considerations and logistics with when we can get in there and burn. But as we go forward, I think we'll be like looking at bumper crops to acorns and factoring that into when we especially once we get more light on the ground, so that they might have a better chance of establishing. Down in the lower slopes, where we're looking to do some timber harvesting at some point, we are trying to be a little more careful, especially, like I said, where we're planting. We want to, if we get that oak regen that we're looking for, we're really going to work to nurture that and protect it.
And as Jeff was just talking about the overall project area, the initial prescribed fire entry in 2019 was fairly small footprint wise, just about 200 acres, and that's to accommodate for and go schedule in concert with other silvicultural prescriptions. So that first one was about 200 acres, and then this recent 2022 spring entry was approximately 330 acres. And again, that's specifically to accommodate for the recent oak planting. So, excluding those areas provided for that about 330 acres. And then in the future, Jeff and our fire program will be working closely together to lay out the next footprint of the third prescribed fire entry.
Awesome, thank you. We are going to take a break in just a moment, but there's a few questions or discussion popping up about pitch pine. I think that the question really is, have you thought about doing any planting or managing for pitch pine, and what are some considerations for southern pine beetle or other invasive insect species that might be in the area?
So we don't have southern pine beetle that we know of. So yeah, there are definitely, there's health concerns with red pine as well, as Dr. Patterson points out. That's something we haven't talked about, trying to introduce pitch pine or plant pitch pine, or it would take a little bit more work to locate or to grow out seedlings or to locate seedlings. But that's something we haven't seen pitch pine on this site, although someone pointed it out. It's not too far away. I mean, that's something we could talk about. As far as red pine, we haven't been planting. We've just been hoping that the management, we're just monitoring and seeing how it responds to the management. But there's definitely potential health concerns with the red pine with bark scale. Other invasive insect species, the spongy moth has been an issue there for sure the last couple of years. Diane's got a question about planting of any near southern pine species like Virginia pine, like an assisted migration type of scenario there. I'm not sure if Virginia pine are affected by southern pine beetle or not. I mean, that's something else we could consider. But yeah, all good points, good questions.
Yeah, thank you. And the Fire Science Exchange. Oh, yay, Kevin Dodds is here. So he says Virginia pine is a southern pine beetle host. Thank you, Kevin. Not that we're happy to hear that news, but I appreciate your response. So the North Atlantic Fire Science Exchange is supporting a lot of conversations around southern pine beetle and fire in our region as well. So we can share links to those. The next video segment talks about prescribed fire and smoke, and then we'll hear about fire effects monitoring. The next segment is about 6 minutes long.
As Jeff mentioned, we've had 2 entries of prescribed fire, both in the spring seasons of 2019 and 2022. And there has been a lot of prescribed fire planning that's gone into the successful implementation. Certainly, as many of you know who conduct and apply prescribed fire, there are a lot of risk mitigation and considerations that goes into putting on a successful and safe operation and achieving the objective that has been set through some interdisciplinary goals. So one thing I'd like to highlight is some advanced smoke modeling that Ralph Perrin, our U.S. Forest Service air quality specialist, had contributed to this project. Ralph had done some modeling of particulate matter 2.5, and I just wanted to show you this little hourly prediction model for the May 1st, 2022 implementation date. And you can see below on the bar here that there's a scale of micrograms per cubic meter of air, and this model is essentially showing the hourly output, and for the most part this is falling within a healthy air quality index, all within that 1 to 2 of micrograms per cubic meter of particulate matter 2.5, and there is some concentrated areas of that 13 to 35, which does pose moderate health advisory if it's in a community. So I want to share that. Also, there's a daily average that's part of this blue sky playground modeling that Ralph put in for us. And the winds were predicted mostly out of the south that day of the 2022 implementation. So we were happy that the model matched up with the actual monitoring that was in place and observation. That's the daily maximum of PM2.5. And then there's also this hourly visual range, which I'll zoom in so that we can get a better extent. Perhaps you can see the color bar of the visual range of how many miles away the smoke was expected to be seen from. I don't know if you caught it there, but there's just a little bit that tracks mostly from the border of Massachusetts up through Bennington and doesn't provide all that much more. You may notice here that there is the Savoy Mountains State Forest, and we've had a few contributions from the state of Massachusetts at the fire towers to provide some smoke column photos. And this one here is actually from the Shelburne Tower, a little farther south. And the photo that you're seeing here from Savoy is marked here in this location. So quite a distance away. We had some pretty good lift on the 2022 implementation. Fire effects monitoring has been established at the Common Stand exam plot locations. Over here on the map, you can see all of these red plot centers, and that represents where we are continuing to use the FireMon's composite burn index burn severity data sheet. This plot center that I've highlighted up here is one of the destinations that we'll be going to for the field day. This heath outcropping with red pine. As you can see from some of the photos from 2019, these are low to moderate severity fire effects and behavior. And then also as a reference for getting up to that red pine huckleberry opening plot up here, for the field day, we'll be meeting at the Dome trailhead and hiking up the Dome trail, and then a little cross country over about 1,000 feet elevation gain up to the top of the Dome. Some results from the fire effects monitoring from our 2019 first entry had been conducted by then Forest Service botanist Aaron Marcus. Aaron is now full-time with the state of Vermont as their botanist. When Aaron did some botanical monitoring, they focused specifically on a rare orchid, Isotria verticillata, common name of large world begonia. This large world begonia had historically been abundant on the Dome. However, in recent years, there's not been much abundance nor any flowering that has been monitored or captured. So after the first entry burn and some silvicultural prescriptions and just opening up the canopy to allow more light to the forest floor, the size and abundance of the Isotria had increased, and Aaron is hoping that as we continue that perhaps some flowering will occur. An exciting note to take away for this is that Aaron's contribution went toward the Fire Effects Information System publication on a species review of both large and small world begonia. I'd also like to note that while we're using the FireMon Composite Burn Index data sheet, it's typically used for more broader landscape monitoring for fire effects severity. But in consultation with Dr. Mike Gallagher from Northern Research Station, we're hoping to ensure that this has a strong role and part in our adaptive management as going forth with future severity of prescribed fire that we'd like to implement. And with that, Jeff can speak more to the 2019 and 2022 vegetation response monitoring.
All right. And I will keep an eye on the chat and see if we have any questions for Lindsay about fire, about prescribed fire and smoke modeling and all the other fun stuff in there. And I noticed that Mike Gallagher joined us as well. I'm sure Mike might have a thing or two to say about FireMon or about composite burn indices and that kind of thing as well. Lindsay, did you want to add any quick comments post video?
Only that what I wrote in the chat there is when we were going over the hourly outputs of particulate matter 2.5, I misspoke, and the range of the modeling was actually 1 to 12, not 1 to 2 micrograms per cubic meter. So that was just the one correction, and yeah, really glad that Mike Gallagher is on. So as we do have further discussion about the FireMon and composite burn index that we've been monitoring with, your contributions are welcomed.
Yeah, Lindsay, if I recall, you made a comment at the end of the video about scale and about the applicability of FireMon. So, Mike, I don't know if you're able to unmute and turn on your camera. Virginia might need to give you permission to do that, but it would probably be great if you could just add a quick comment or two.
Hey there, can you hear me?
We got you, Mike.
Great. Yeah, well, so I guess my comment would be that I've done a lot of work with burn severity indices. So FireMon or the composite burn index being one field method. that you can use. And then there's also the difference normalized burn ratio, which is a satellite-based method or reflectance-based method. I guess I would just say that while you can get a pretty picture with remote sensing data, you always need to calibrate it to something real on the ground to make it more than a pretty picture and to give that picture some meaning. So this is something that we've been talking about a bit with Lindsay on the Green Mountain. They've got some great field data, and there's sort of an opportunity to scale that field data from plots to wall-to-wall measurements or predictions, really, via the satellite approach. And so we're also using some new. There's a little bit of there's a lot of subjectivity in that field approach with the composite burn index sheet. It's something I've published myself, though, on using those sheets. So it's sort of the best thing we have today. But we're developing some new techniques using terrestrial LiDAR that would make it easier to collect observations with the push of a button and a much more consistent measurement. So that was something that I visited with Lindsay and some of her team with over the summer. And we've been testing in New Jersey, and we're hoping to expand that in the Northeast and Mid-Atlantic soon as we can.
Awesome. Thank you, Mike. All right. Surprisingly, I'm not seeing questions in the chat about fire, about Pagonia, about anything. We'll give folks a moment to type in the chat. Also, let's maybe give permission for folks to unmute if they would like to ask a question out loud. I'm sure Virginia is on top of that. Granted. All right, so I'll be quiet and let people ask a question out loud.
I have a question, actually. I'm interested to know how many people have tried to assess burn severity for either wildfires or prescribed fires in their area.
So to answer that, maybe folks could just type in the chat if you have done that, looking at burn severity in wildfires or prescribed fires in your areas, so Mike can see. Some familiar names in there.
And I might add that Joshua Shanto, who's on and has done this, was here detailed to the Green Mountain National Forest in my position. So was conducting all that prescribed fire monitoring using the composite burn index. So that was wonderful to have Josh's presence, contribution, and experience from other more formalized fire effects monitoring training.
So that's really great. I'm happy. I appreciate everybody's comments in the chat box there because it's something I kind of feel like I talk about, and I really don't know how many people are actually using it in this region. It's something that was a tool that was developed out west, and it's useful in the east, but it also has some limitations in its design, at least using the field method, in that we have fire in different phenologies here. And so we have a dormant season where there aren't a lot of leaves in the forest, and then a growing season where there's more leaves. And even in a pine forest, the leaf area increases substantially during the growing season, and then pines drop a lot of needles before the winter. And so I'm really interested in working on this some more to develop a method that could apply to both spring prescribed fires during the dormant season, as well as growing season wildfires or growing season prescribed fires, if folks are doing that. Something that's robust across phenologies. And we're hoping that this, we've got a lot of data from our pitch pine forest in New Jersey, from wildfires this summer and some prescribed fires, and really looking at trying to test a new idea with this terrestrial laser scanner that would be robust to multiple conditions. And so I'm taking notes on who said that they've helped here, and I might pick your brains or look for your input down the road. So thank you.
Yeah, thanks, Mike. And actually, Mike, if you could type your email into the chat and just a reminder to folks to contact you about composite burn indices or fire effects monitoring, that would be great. Let's see, Josh said, it was definitely my pleasure to be part of all that. So thank you. And then Inga says, one of our biggest challenges in land fire is mapping recovery after disturbance. We need more pre and post disturbance field data, repeat measures with time since disturbance. And Keith also adds, Brenda Dale was burn boss in 2022 and did a great job organizing implementation and managing the prescribed fire. So awesome, awesome. I definitely love hearing all the collaboration that goes into managing at the Dome. This is excellent. I'll be quiet for a moment and let people make a comment. Lindsay, did you want to go?
Yeah, I do have something. And just to add on, the reason why we really adopted to using FireMon's composite burn index data sheet is in hopes of also just illustrating our prescribed fire effects on a given resource of concern. You know, you have the different substrates, and whether it's soil, duff, litter, small vegetation, looking at that as a means to communicate across our resource areas within even our forest. We often do very, very detailed analyses of proposed projects, prescribed fire being one of them. And so much of the northern New England prescribed fire effects are not very well known. We don't have a lot of that data available to us. So again, we look to NAFC for connecting us and sharing that information so that we can, you know, better make future management decisions using fire as a tool.
Yeah, thank you. So we have 2 more video segments, and I think the next one is about 8 minutes long. So we'll get that rolling. Please add any questions in the chat, and we'll see you in about 8 minutes back here.
So what else have we learned so far from our vegetation monitoring efforts? The vegetation data we collected after the first burn in 2019 didn't give us a whole lot to go on, though it was useful. But it didn't show a huge departure from the pre-burn data. As Lindsay discussed, the fire severity was generally low, so there wasn't a lot of mortality in trees bigger than seedling size. Seedlings and shrubs were generally top killed, and they mostly resprouted after the burn. The burn was done at the very end of the dormant season, and we tried to burn just after bud break for most of the northern hardwoods, but we still had a vigorous sprouting response for most of those species that do sprout, like beech and maple and serviceberry. The good news is that the oak and sassafras sprouted pretty vigorously as well. We did see an increase in the number of oak seedlings. That was mostly individual seedlings that had been suppressed or heavily browsed, that when they were top killed sent up 2 or 3 new stems to replace a single old stem. The sassafras response was also really robust in areas where there was some sassafras present. And you can see that in this photo here, where it really came back to a thick carpet of sassafras, and that seemed to happen anywhere that we had sassafras, and it definitely didn't look like that before. So we did observe some delayed vegetation responses as well in the next couple of growing seasons after that first burn, and some saplings and mid-story trees that leafed out after the burn may have later died in response to that stress, or at least died back. The fire might not have killed them instantly, but it caused stress that they couldn't really recover from. Other changes in soils or in light levels could also have taken a few seasons to play out. And these changes were not all captured in the 2019 data, and we didn't collect data between 2019 and 2022. Going forward, I think it'll be valuable to collect data again 2 or 3 growing seasons following a burn, so we can capture some of this delayed response. Overall, I think we got good results from this 2019 burn. The burn severity was generally light, as Lindsay described, but it was a good first entry. And we learned a lot about how to do the burn, and I do feel that we got some positive results on the ground. The data we got in 2019, along with our later walkthrough and observations, did give us enough information to go on to recommend another burn. And we just finished with data collection in the treatment area following the burn this last spring. So I'm really looking forward to seeing what comes out of that data. It's going to be especially interesting to see what kind of cumulative changes have occurred in the 5 years after that first burn, along with the effects of this more recent burn with the moderate burn severity. So we've learned a lot in this process, which is part of the point of adaptive management. We've learned about how and when to use fire, and how and when to monitor, and how to coordinate all the different things we want to do out there in the landscape. It's going to be at least a few years before we burn the treatment area again, but in the meantime, we'll be taking a hard look at the data we have, and we'll be looking to collect additional vegetation data over the next couple of years as well to capture those effects, those cumulative effects over time that I mentioned. And this is going to inform how and when we burn, and if we burn. And it's also going to help us decide whether we might need to try some mechanical methods or other techniques to meet some of our objectives, especially related to beach competition. There's other monitoring work going on out there, which we'll hear about. The monitoring work that's being done by FEMC is going to add a lot to our efforts here, I think, and it's going to be really valuable going forward. And I'm certain that the project's going to continue to benefit from all the support and expertise of the folks here and with us today and in the research and management community. And I'm looking forward to working with you.
Hi, everyone. I'm Suzanne Gifford, ecologist and wildlife biologist for Green Mountain and Finger Lakes National Forest. So glad this day is finally here, and grateful for all the wonderful collaborators we have. Particularly as part of the dome work, we have relied heavily on collaborators. As the Forest Service, we're limited in our capacity to perform in detail monitoring beyond what we've been able to present today. Our collaborators include the Nature Conservancy Land Fire, as presented by Randy Swati earlier. They have done detailed analysis and provided the context of historical fire regimes. Vermont Center for Eco Studies, we'll hear from next. They're doing some very exciting additional monitoring work on creating a model for rigorous fire management monitoring in dry oak habitats. And finally, the U.S. Forest Service Northern Research Station is providing and interpreting ground-based LiDAR technology to understand fire fuel loading and vegetation changes in greater detail. So our next presenter is Ryan Rebozo from Vermont Center for Eco Studies, presenting on the detailed monitoring that they've initiated this year and will continue into 2023.
All right. So thanks for that last video segment. Suzanne and Jeff, I think we'll probably want you around to answer some questions. And you got a little teaser for Ryan's presentation in just a moment. So a question that came in is, what is the size of your inventory plots?
Yep. Yeah. No, so for the overstory, it's their variable radius, their 20 base area factor plots. The understory, we used, I believe it was a 6.8 foot radius regeneration plot or subplot for that data.
Great, thank you. We'll give folks another moment to type a question into the chat. All right, so I'll read Tom's question out loud. He says, I may have missed it, but are those non-fire adapted tree species like the white birch that I saw in the burn pictures going to be removed and thinned to a woodland canopy structure, 30 to 70% canopy cover to get that light in?
Right now, we don't have any plans. I mean, I think as far as doing mechanical treatments or like non-commercial or commercial thinning type treatments, we're kind of taking that adaptive management approach. So the data from this, we did monitoring in September. We collected data on those plots again following the spring 2022 burn, and I think that's gonna give us a lot of information to kind of make future decisions about what we need to do. If we were gonna do some kind of mechanical treatment or thinning type treatment in there beyond fire, I don't think that birch would be targeted. White birch, I think we would be looking mostly at, we'd be trying to do some pretty minor adjustments to the light environment in there. I think we'd focus more on beach where we had beach competition, which seems to be a bigger issue for getting oak established and for mesification. But I can say just unfortunately, we've collected the data, but it's still kind of being processed and compiled. I was hoping to have some more data from this most recent these measurements to share, but we don't have them today. But just talking to the crews that were out doing the work, one of the things I heard a few times was how much easier it was to do the plots on the burn side than the control side, because it's so much more open underneath. They reported a lot of mortality in mid-story and understory beach. I suspect that some of that is cumulative from the first burn, and then this one may have just kind of put them over the edge, and it was a little more intensity, so we probably killed some larger mid-story beech and hardwood trees as well. And the shrub layer, it sounds like, just talking to folks, is still largely intact. It's just shorter because it's all resprouted, so it hasn't grown to that same height that it was before. But I'm hoping that we'll have at least some preliminary data or information to share on some key metrics at the Friday field trip.
Great, thank you, Jeff. Let's see, Lindsay or Suzanne, did you want to add to that?
No, but I do want to mention, if we transition over to talking about more fire effects or silviculture response of the Isotria verticillata, Aaron Marcus is on and available to provide any further and more intimate knowledge about that response.
Excellent. So bring your Isotria questions into the chat. We have a couple of comments. Tim Simmons says, for the 2019 fire, fine fuels were still compacted from snowpack. So interesting, and how that might have affected the fire effects. And then Dr. Patterson adds, paper birch, one of the most important woody species for indigenous people. I suspect they knew a lot about paper birch silviculture. And he also mentioned sassafras as another target for indigenous burning earlier as well. And then Andy has a question. He says, any considerations of non-traditional burning seasons, for example, fall or summer? So Lindsay, what do you think about burning in another season?
I certainly think that, in concert with Jeff, we would need to time that for like a fall burn. However, what we found locally in both on the Green and the Finger Lakes for prescribed fire, oftentimes it's hit or miss when we plan for a fall prescribed fire entry. Seldom do the windows of opportunity really align, and conflicting with qualified resources who are usually working on more of a national scale for fire support. So that really early spring, it tends to be our availability for both fire fuel conditions, weather conditions, and qualified firefighters. I'd say we'd be open to it, but it's kind of a larger discussion that we'd need to have and do that well in advance, or maybe on a drought year when we would expect like some really warm fall days.
Yeah,
drive.
we never know when those will happen, but history tells us they do happen occasionally. So, all right, let's see. Does anyone want to ask a question out loud? Oh, we have an Isotria question. Maddie is asking of Aaron, can you tell more about the Isotria population? What is the species range and size of the population relative to that? And are there critical fungal relationships that are affected by fire and silviculture?
Okay, I'll try. Let's see. Can you hear me?
We can hear you, and now we can see you.
Okay, one part of that question at a time. More about the Isotria population. So Isotria verticillata large world pogonia is listed as threatened in Vermont, within the state of Vermont, and is a S2, so it's on a rare plant list and is a regional forester sensitive species. For those who aren't familiar, this is an orchid species. Really, the large world pogonia is getting toward the northern end of range here. We do have populations that go all the way north to Chittenden County, so a few counties north from here. I think the species is S3 in Massachusetts. This is actually probably one of our largest, or maybe the largest population we know of within the bounds of Vermont. It's the estimate is there's well, in the 80s, which actually there's a question that was directed directly at me about defoliations in the let's see, it was about defoliations in the 80s or 70s. Anyway, in the 80s, there were estimated of about 1,000 plants in the early 80s. In our inventory before the burning in like the mid 2013-14 region, I would estimate there were a similar amount. There were probably more dormant plants that weren't coming up. And following the fire, the numbers did increase pretty dramatically, but only in the areas that were burned. The plants are also larger, which is similar to what we see. We actually have done some much more detailed sort of experiments. This is work that Warren King did, one of our volunteers, up a couple counties north of this population, another population where there were some silvicultural treatments that I would say imitate some of these, maybe had some of the similar effects that fire might have in terms of how it benefited the species. And we saw really dramatic, patch cuts were not great, but anyway, thinning operation compared to controls really did seem to benefit the species significantly there, and eventually the plants started flowering. I should mention this population doesn't. Before the burning, there was, I think, I only ever, out of those 500,000 plants, I only ever found 2 seed pods. So they just were not reproducing by flowering anymore. And we don't actually have the data. We didn't have the resources to gather data to follow them into flowering, which I expect they have done subsequently. But we do have but usually when they get larger, that's like in the subsequent years, that's what we've seen in other places, is that they will flower. Yeah, I think that's what I can answer from. Oh, as far as fungal relationships, that's something that I think would be really interesting to study. I'd love to see more of that. The Forest Service did not. I did see a lot of fungi on the soil where they were growing the year after the fire. A lot of mycorrhizae in the soil, but it's really, that's something that I'm super curious about and could be a really great monitoring project that I'd love to see with maybe NAOC or another group. Like, I don't know. So I would love to see collaboration, understanding how these plants are, because this orchid and other orchids are mycorrhizal.
Awesome. Thank you, Aaron, so much for that response. And Maddie says, very cool. Thank you. I encourage the two of you to connect, because Maddie, I think, would love to nerd out more on botany. We have a comment from Brenda. Brenda says, the UP used to burn a lot in the spring, and we moved to burn our conifer encroached wildlife and fuels openings to a growing season burning. The fire effects were different and much better. The blueberry plants were still very flammable and were able to carry the fire. The conifer were more susceptible to mortality, so we were able to set the encroachment back. The veg around the burn units were also in green up, so less likely to escape holding lines. Birch responded well to fall burning, and indigenous burning would make more sense after harvest. So thank you for that comment. That's helpful to hear about from a similar landscape. Bob had a question. Is S3 uncommon in New York, Massachusetts, Connecticut, and more common to the south? It doesn't occur in Maine, and is S1 in New Hampshire? I don't know if anyone can answer about the S3. I'm kind of looking at Suzanne. I don't know if you know.
I'm reading his as a comment. It is S3. I think he's providing us some additional context.
Yeah, S3 is uncommon, and actually sassafras is S3 in Vermont bounds, and that is probably our largest population again at that site, and has also responded well to fire, as Jeff spoke about.
Awesome, thank you. And perhaps to wrap this section up, Lindsay had a comment agreeing with Tim's comment earlier. The first prescribed fire entry in spring 2019 was on the cool end of the burn plan prescription, contributing factors being snowpack and also general atmospheric conditions that week, with 10-hour dead fuel moistures in the 12 to 15% range. So we have about 20 minutes left in our scheduled time, and we have one more video segment that I'd love to play for you. So it is about 5 minutes long, and we'll conclude the video segment there and then finish with discussion. Thank you.
Hi, everyone. I'm Ryan Rebozo, Director of Conservation Science at the Vermont Center for Eco Studies. I apologize for not being able to be there in person, but I'm happy to have the opportunity to talk just a little bit about a project we started this summer in partnership with the Green Mountain National Forest and with funding from the Forest Ecosystem Monitoring Cooperative. We were interested in taking a look at the efficacy of prescribed burns in dry oak habitats. Some of you might be familiar, but dry oak habitats are an S3 plant community in Vermont, specifically in the site where we were working, which is the Dome in southwestern corner of the Green Mountain National Forest. There are two variants of this habitat type, both a beech and a heath variant. And the interest in using fire in this specific site is to address mesification, where beech and red maples are becoming a larger component of the forest. So this area was approximately had half of its area burned. The other half was unmanaged, functioning as a control, with the Dome Trail bisecting these two areas. So we know prescribed burning can be a beneficial management tool for the regeneration of oaks, and we expect this to be the case by reducing competition with other plants, reducing the litter depth, and increasing things like light availability to the forest floor and the availability of nutrients in these areas as well. But we also know that the benefits of fire to oaks in these types of habitats can be highly variable, and the outcomes can depend on initial site conditions, the timing of the fire, size, class, structure, and confounding effects of things like herbivory and plant competition, especially invasive plant competition. So in order to see how this area was responding to fire and comparing it to the unmanaged half of the site, we used FIA Phase 3 methods, taking a look at not only the canopy trees, but saplings and seedlings on site, different cover classes, the herbaceous plant community, insect and deer herbivory on site, and measurements of both litter and duff layer depth. We also used the Leica BLK 360 laser scanner to scan the understory for detailed forest structure measurements that would aid in the comparison of these sites as well. The next step is to come in late winter, early spring, and use drones to survey and come up with estimates of local deer density. We like this kind of time of year because it'll be after the hunting season, after peak winter mortality, but before fawns are born. And we think that's an ideal time to get a good estimate of what the local density might be. And our interest in deer density is related to herbivory and what that might do to regenerating oaks. Models show southern Vermont as having some of the highest probability of ungulate browse impacts to forest lands, certainly in the state, but even in northern New England in general. So we think this is an important piece to add to our monitoring of this site in order to better gauge what trajectory this forest is being set in. Ultimately, we hope that what comes out of this can better inform the use of fire in these sites and maybe even expand the use of fire where it's appropriate in the national forest. So we look to contribute what we can. We would like to continue monitoring these sites and add to it over time. And I'm happy to hear what others are doing using fire in northern New England, and happy to answer any questions that people might have as far as what we're working on. Best way to contact me would be through email at rrebozo@vtecostudies.org. Thank you.
Not only is all of this work important for understanding the Dome site itself, we're also looking to the future to expand potentially our fire adapted landscape management. In particular, we're looking to the northern escarpment area on Green Mountain National Forest. So the Dome site being here. The orange highlight is the escarpment management area as defined in the Green Mountain National Forest forest plan. And this portion being the northern escarpment where we've conducted some initial field work and exploration. As these photos show, looking at oak pine communities, we've got areas of pitch pine, huckleberry, blueberry, chestnut oak, areas with chestnut red and white oak combined, ridge tops where we're seeing evidence of past fire and past disturbance on the landscape and exploring the potential for future management with prescribed fire. Many thanks to our participants and collaborators, particularly Diane Burbank, Joy Phelan, Aaron Marcus, Ralph Perrin, Randy Swati, Ryan Rebozo, Greg Nowacki, and the Interagency Wildland Firefighters for all of their contributions to this project.
Yay! Great video, great conclusion. All right, there's been some great conversation going on in the chat, but in the interest of time, I'm not going to read all of it out loud, but just a quick tip, you can save the chat. You might want to wait till the end, but there's should be a little ... and you should have an option to save the chat. So you can save the chat and check out these and other resources that folks have been mentioning in the chat window. Also, if you haven't figured out, you can also private message people. So if you want to connect with someone that you've heard from on this webinar, then that would be, you're welcome to do that as well. And if you want to get in touch with folks, to contact us at the North Atlantic Fire Science Exchange, and we can also put you directly in touch. Virginia can drop her email in the chat and we can connect you with folks that you're looking for. Boy, lots of great stuff here. Thank you, Virginia. So we have about 13 minutes left until the top of the hour. Time flies when you're having fun and talking about the dome and fire ecology and oak and silviculture. So in the time that we have left, we are hoping to hear from just a couple more people. So we've heard some really great specifics about what's going on at the dome. But here, I think we have, let's see, I'm sorry I'm going to butcher your last name, but Matthew Vadeboncoeur, if you're able to unmute and turn on your camera, Lindsay was hoping you could share a little bit about your NSRC research and just what are you thinking about in terms of oak restoration and fire in your work?
Yeah, absolutely. Thanks for the opportunity. So I'm Matt Vadeboncoeur. I'm a research scientist at the University of New Hampshire in the Earth Systems Research Center. And I'm getting a project started with some funding from NSRC, looking at the mechanisms by which fire affects red oak seedling success at or near its northern range limit. So one of our long-term goals is to be able to recommend strategies for adaptive silviculture, successfully introducing oak into the species mix to create a more functionally diverse and climate-ready northern forest in an area that's sort of beyond what we think of as a current commercial range limit for oaks. So I should mention this collaboration with Nat Clevitt at Cornell and also with UNH Cooperative Extension and the Forest Service. So there are 3 components to this study, which will start in the spring. First, we'll be doing surveys and studying seedling density, growth rates, soil nutrients, and root pathogen loading in silvicultural prescribed burns that have been done over the last 2 to 7 years, and comparing with cut or thinned nearby stands that were not burned. These stands are all in the White Mountain National Forest, where we're working with John Neely and Marco Yamasaki. Second, we'll be doing a potted seedling experiment with soil that was collected either just before versus just after a small prescribed burn, which we'll implement here on the UNH campus. And that'll be to look at basically the soil effects independent of light and root competition that you might experience in an actual forest environment. Again, the idea of getting a better handle on mechanisms why fire seems to help oak regeneration. And third, we'll be doing a retrospective analysis looking at older fires, either prescribed or wildfires, looking at the age structure of oaks versus trees that are either more dependent on fire or less tolerant of fire in the same stands. So this is the piece that I could actually use some help with because I'm looking for stands that have burned in the last 30 to 100 years, ideally in a known year, but not necessarily, where red oak is part of the species mix and little or no additional management has occurred since the last known burn. I have a few candidate sites identified across New Hampshire, but it would be really great to expand the geographic coverage into Vermont and Maine as well. So if there are sites that you know of that might fit that, it'd be great to hear from you. Final component of the project was we're hoping to do some outreach and get our results out to stakeholders and the interested community. And actually, I think this workshop is a really great model for what that could look like. So thank you very much to all the organizers. So I'm really looking forward to seeing the Dome on Friday and speaking with some of you about your experience, the challenges of oak regeneration in the silvicultural context, and also any recommendations you might have for how we should design our data collection protocols to make sure that the data we produce are maximally useful to the community and also maybe comparable with monitoring efforts like the ones we've heard about today. I'm going to put a link in the chat here that has just an abstract for the project and also contact information for me. So thank you.
Great, thank you, Matthew. We have about 9 minutes left, and boy, I wish we had more time for discussion. And I'm excited for the people that are going to be able to come join us on Friday at the Dome. For other folks who are here right now, just take a peek at the chat. Maddie's sharing some links to some really great resources. And again, you can save the chat to save those links, and we can also email those out before. Well, Virginia emailed some before, but we can also remind you afterward in case anybody registered at the last minute. But in the 8 minutes that we have, I'd love for people to have a chance to unmute and hopefully raise your hand so I can see you. And if you have a question or a comment, that it would be great to hear from you. I'll try to call on you. We have a few topics that were brought up. So what, based on what we've learned at the Dome, what are you thinking now? How does this affect your thinking in fire as a tool in oak restoration? We also had some lively conversation earlier about fire scars and what they tell us, conversations about other species, more like tree species options at the Dome. Lots of great side conversations about fire effects monitoring. So there's a lot going on in this virtual get together here. So maybe in the last few minutes, I'd love to hear from each of our speakers, any kind of final take-home thoughts that you'd like our folks, our participants here to think about.
I'll go ahead. Yeah, and from contributions from Dr. Bill Patterson to the conversation, and all of our Dendra specialists who are on here for fire history, I think it's a nice forum for us to kind of come together and talk about fire's role on the landscape in these northern New England forests, and having some sort of follow-up. What would that look like? How can we continue to stay in touch throughout these conversations? So ideas about that, let's think about it.
Sounds great. Thank you, Lindsay. I don't know if Jeff, Suzanne, Randy, or anyone else wants to pipe in with additional thoughts.
Yeah, I guess just to reiterate that this is an adaptive management approach, and that we're constantly learning and reevaluating and looking at what's working, what isn't working, and trying to keep up with all the great and new emerging science that's out there. So we are, as part of that approach, we are kind of looking to this community, to the practitioners, managers, researchers, for input and advice. So please feel free to reach out to us to get updates on the project. If you've got thoughts or input or things to share, I mean, we're trying to be as comprehensive and holistic as we can. But thanks for being here.
It's a big job.
Randy,
go ahead, Randy.
Yeah. Thanks, Amanda, and everyone. As I hinted at earlier, I am happy to hold a landfire data, landfire models kind of working session Zoom, where we dig into like an ArcGIS project and really dig into the spatial data or the biophysical settings models where we got the fire return intervals. I know that 3-minute video was just really short, so I'm happy to host that. And would love to get feedback. And as Inga mentioned in the chat, Inga's more tied to the landfire production team than I am. And I know they are always looking for feedback, especially pre and post disturbance data to help them with their modeling. So I think I can speak for Inga. We're happy to take feedback, and I'm happy to host a landfire data review Zoom if that's helpful. I know that's just one part of the puzzle, but I can definitely do that.
Awesome. Thank you, Randy. Suzanne, did you have any final thoughts to share?
Sure. Again, echoing the thank you to everyone. It's so wonderful to see so many names and so many great contributions to the conversations. One thing we've touched on but haven't really said, I guess, outright, is given these systems, these these areas, these vegetation communities are somewhat small and isolated. This restoration is an important and significant contribution to the diversity of the forest. And building that diversity is one of our best strategies in looking ahead to climate change and building resilience. So again, thanks to everyone for being here. Really appreciate it.
Awesome. Thank you, Suzanne. So we just have a few minutes left. So yeah, I guess if anyone has final questions or comments, please feel free to type into the chat. At this point, I might let us wind down just a few minutes early, but people can stick on for a minute or two if you want to chat with some of our folks. And I would encourage each of our speakers to drop your email into the chat window as well, so that people can reach out to you directly if they want to follow up on something that you presented. And just as a reminder, Regina had emailed out to people that registered early a link to the video that you saw snippets of today. And I think we can do a follow-up email again with that link to everybody who participated today, and also links to the papers that Maddie shared in the chat window. So we'll definitely follow up and keep you in touch. And I'm so thrilled by the great conversations that have been started in the chat window. It's amazing how much you can cover in 2 hours, and I really appreciate everyone's focus and attention this entire time. So thanks everyone so much for joining. Thank you so much to our presenters for taking the time to prepare the video and share the story map and talk about your work. And I hope that everyone here will keep in touch. Thank you.